We were talking earlier about air pressure, and it's gravity that holds the air down on the earth and gives us this pressure. And we also know from experiments done a few hundred years ago that gravity works on all kinds of things, and even if they're different, it works the same way. So if I were to drop this medicine ball that weighs about 15 pounds and this softball, they'd hit the ground at the same time if I released them at the same time. But then the question came, what if I drop this and at the same time push this out that way? Would they hit the ground at the same time or not? Well, let me try it. Let's see if we can do the experiment. I'm going to drop the medicine ball and throw the softball out. Well, you know, that's not a good way to do an experiment because I'm not sure I did it just right. But Jack is up there, and Jack has the right stuff to actually do that experiment.
I've got a device up here that will throw a ball out in that direction. At the same time, it drops one down behind here without moving it forward or backward. So what I'm going to do is hit this little lever up here, and those two will be released at the same time. Now, what you should do to see whether or not they land at the same time is listen for the time when they hit the ground. If you hear it just go bang, then you know they both hit at the same time. If it goes bang, bang, then you know they've hit at different times. So we're going to give it a try. If you'll give me some help, we'll count to 3, and we'll let it go ahead and do it. Are you ready? Hey, was that one bang or what? Yes, it doesn't matter. It doesn't matter if it's going forward or not. It lands at the same time from the same height. That's physics, man, and that's fun stuff.
If we're going to start shooting things, we better have a little better cannon. This cannon shoots these projectiles. And of course, if you shoot a projectile straight up, a cannon straight up, it's not a great idea because you're going to be where the cannonball comes down. But here's how it looks. You fire it straight up, but you better be alive because it comes right back down.
Now, if you want it to go the farthest distance you can, the physics tells you you don't shoot it straight up. We've just seen that. You don't shoot it straight out. You shoot it halfway between the two. You shoot it at an angle of about 45 degrees, okay? And that'll get you the maximum range from where the muzzle is to catching it at the same height.
So now I'm at 45 degrees, and we're going to get this projectile to go as far as you can with this cannon.
Right about there. Now, this is the maximum distance. If you change the angle, it shouldn't go any farther than this. If I could I have a volunteer over here, Melissa. If you could come right over here. We've never met before, right?
Never.
Okay. Now, she's going to mark the maximum distance. Hank is going to put it at a lower angle. It's going to look like it's coming straight at Melissa, but it won't reach her. It'll be less. You know why I'm having you mark this distance instead of me?
No.
The university changed insurance companies this year, and they really don't have good coverage anymore.
Now this is 15 degrees too flat. So the projectile really races down there, but it doesn't stay in the air long enough to get the same range. So it's going to fall short. 15 degrees too flat, goes like this, lands about there.
Same height, not as far. Now, one of the curious things is that was a low flat shot. If Hank passes the angle for the maximum range and goes over it, it'll now shoot a big arcing shot, but still come to the same place.
So here's 15 degrees too high. Now, it's odd, but every degree on the opposite side of 45 goes the same distance. So this ought to land right in Dan's bucket because we're 15 degrees too high. Oh, it's a lovely shot. It goes up in the air. It's pretty. But it doesn't go down very fast, so it lands short.
Right about there. About the same place, right, in both cases. Good. Thank you, Melissa.
What you got here is you got your basic poor man's Mercedes. Okay? And what I'm going to do is I'm going to shoot a ball straight up in the air, all right, but it's going to go in that direction at the same time. Because relative to me, it'll stay right straight above me. I'm going to go through the tunnel. I have to get in my machine here. And I'm going to go through the tunnel, and the ball is going to go up and over the tunnel, and I'll catch it on the other side. Because we're both going the same speed in that direction. Okay, Fred, are you ready?
Well, we better test you because Jack's driving isn't so good. So we're going to make sure you go through the tunnel.
Okay, here I go through the tunnel. Hello, remember me? I was over there. Yeah. Okay, how am I doing, Fred?
Well, you're driving in a straight line. That's what we need for this.
That's what we need for it, you bet. Now, I can do this. I just know I can. Okay?
Deep breath.
Deep breath.
Here we go.
Now, you know, we've been using some little bitty cannons. I think it's time we need to get out the big stuff, don't y'all? How about this one? Now, for this demonstration, we know that gravity acts on everything, whether it's moving or not. So I'm going to shoot this cannon at Hank when he's at the top of the gantry. But if I do that, as soon as the cannonball leaves the end of the barrel, gravity's going to start pulling it down. And if Hank's lucky, it'll miss him. It'll go underneath him. So how can we make sure that that doesn't happen and I get to hit Hank? The way we're going to do it is at the moment the cannonball leaves the end of the barrel, we're going to drop Hank. I like this one. Now, to make sure that happens, we have a magnet that's powered by the cannon that, you ready, Hank?
Yep.
Is held in place. And I said that whenever the projectile, the cannonball, left the end of the barrel, it was going to drop him, and this is what's going to happen. When it leaves the end of the barrel, there's a switch that drops him. So, that's what we're going to do. So, we're going to put this thing back together. You ready, Hank?
Yes.
Power's on. And to make sure that this is pointed right at Hank, I have a laser that I'm going to have in the end of the barrel, and we're going to shine it right on his baseball glove. And then we know it's pointing straight at him. Okay? And away he goes.
It's good.
A little more. It's, hang on. Okay, that's fine. Okay, Hank, can y'all see the laser beam on the back of his glove? Okay, so now we know it's pointed right at him, right? So I'm going to remove the laser pointer. That's out. And the first time I fire the cannon, we're not going to drop him so that you can see what the cannonball looks like as it's flying across the stage, okay?
Now,
Here we go.
If I don't drop, he can't hit me. Because gravity will bend the bullet away from me.
Count
Below
of three.
me.
1, 2, 3. Okay?
Now, the next time he fires it, I'm going to fall. And the bend of the bullet and how much I fall are going to match, so I get to catch the ball. Now, let's say he shoots it faster this next time. If he shoots the bullet really fast, it gets here so quick that I don't fall very far, but it doesn't bend very much. So I just catch it down here a little bit. If he shoots it slow, it takes a long time to get here. I fall a long ways, but it bends a lot, so I catch it down there by the mat. If gravity didn't even work, I wouldn't fall and the ball wouldn't bend. I'd catch it right here. Nothing can go wrong with this demonstration.
Say, Hank, before I shoot the cannon, do you remember the comment you made about my brains coming out of the back of my head? I'd like you to think about that as your life passes. I'm going to arm it.
Yes.
Ready? It's armed. Okay, a little help. On the count of 3. 1, 2, 3.